Hello again, class. So today we're going to talk a little bit more about the work and energy relationship, and then we're going to talk about kinetic energy. So if we start with work is equal to delta E. So I mentioned it yesterday, and I know it probably confused a lot of you, so I just wanted to clarify that a little bit. Firstly, energy is the ability to do work. So right away, you should know that they are connected with each other. The mathematical relationship for them is that work is equal to the change in energy. Remember how that delta means change? So that would be E2 minus E1. Future physics courses you'll go into a lot more depth on the work energy theorem, but for this course we're just sticking with E2 minus E1 is equal to work. Now, why this is the case is basically because you know that energy can't be created or destroyed. So therefore, if somehow you add energy to the system, that adding of energy is through work. Or if energy leaves a system, it leaves through a different form of energy. So oftentimes that's going to be through work. It's going to do work on some other system. Or it'll lose heat. It'll create thermal energy. So it changes its type of energy. Now if you think about an example of lifting a book off the ground to a height of 2 meters. So we have our book on the ground and we bring it up 2 meters. I'm going to move it up there. So at the bottom, our potential energy, which again is equal to mgh, is equal to 0 because our height, this height is 0. Therefore our whole thing is 0. Now, if we look at the top, our potential energy is mgh, which we have a 1.1 kilograms times 9.81 times a height of 2 meters. That's going to give us, just grab my calculator here, 1.1 times 9.81 times 2 is 21.582 joules. Okay, so we're going to come back to that. But notice how there's a delta there. There's a change in energy. Therefore, work has definitely been done. Now, if we looked at it in work is equal to force times distance, then the force required to lift up a book is 10.8 newtons to lift up 1.1 kilograms. And the distance that we're lifting it is that 2 meters as well. So 10.8 times 2 is, look at that, 21.6 joules, which, because I rounded this number here, is the same as this number. Now, using the potential energy, we know that our EP2 is equal to 21.582 and EP1 equals 21.58, oh sorry, EP1 was 0 joules. Our change in energy is equal to 21.582 minus 0. I'm going to change that to 21.6. And if we look at the formula, work is equal to delta E. Well, our work in this case, 21.6, and our delta E, 21.6. So work and energy are almost the same, but they're very related. In this case, our system is the book, and the energy of that book was 0 at the beginning. So the system itself had 0 energy. And then there was work being done by an external source. So that would be you lifting the book up. You're adding energy to the system through work. You are doing work and that system gains energy. So that's how they are related to each other. I hope that makes a little bit more sense and a little bit more clarity for you. If we move on to kinetic energy is the energy of movement, for motion. If you think about, it's easiest to think about a person running. An adult running has a lot more energy to do work than a child running. They just have more mass, they have more speed, they are running with more energy. So think about trying to tackle a football player. You have a football player just standing there, and your job is to tackle them. In order to do that, two things are really going to help you. One of them is going to be your speed. If you run at them slowly, you have a less chance of taking them down than if you run at them with a faster pace. So that's your speed there. Notice how it's speed, not velocity. Another help is going to be your mass. Having a heavier mass is going to be able to take down the football player a lot easier than a lighter mass. Think about your sister who is 5 years old. If she's trying to run at this football player, and if you are in grade 10, you're probably going to be a lot more heavy than your sister who is 5 years old. Your sister is going to have a harder time taking down that football player than you are. So mass and velocity are the two main drivers for kinetic energy. Now unfortunately I can't derive for you how we got to the kinetic energy formula, but it's through calculus and it's based on these mass and speed variables. The formula is 1/2 mv squared, where kinetic energy is measured in joules, mass is measured in kilograms, speed is measured in meters per second. And the reason I have two formulas here is because some people like to see it as mv squared over 2, other people like to see it as 1/2 mv squared. They both mean the same thing, it's all just math on how you write that fraction, because that 1/2 is just in front, whereas 0.5 times mass times speed squared is the same thing as mass times velocity squared over 2. So, perfect. Let's try an example. What is the kinetic energy? So we want to find EK on a 1600 kilogram car. So our mass is 1600 kilograms, moving at 2 meters per second. Well, our formula is EK is equal to mv squared over 2, which is 1600 times 2 squared divided by 2, and that's going to equal 3200 joules. Now, two significant digits, so I'm going to make it into kilojoules. I'm going to do EK is equal to 3.2 kilojoules. The alternative would be 3.2 times 10 to the 3 joules. Both those would be acceptable answers. So that's just a simple plugging in the numbers into the formula. If we were to ask for a different variable, we're going to try and find the mass. We don't know mass. We know that the person's running at 0.9 meters per second. And that they have 200 joules of kinetic energy. We want to solve for mass. We have everything we need. EK is equal to mv squared over 2. We need to solve for this mass here. So in order to do that, we're going to multiply by 2 to both sides. And you get 2 EK equals mv squared. Now we can divide both sides by v squared. And that'll cancel your v squares. And you end up with 2 EK divided by v squared equals mass, which is 2 times 200 divided by 0.9 squared equals 493.8 kilograms, or 4.9 times 10 to the 2 kilograms. And that would be our final answer. So it's not super difficult if you have all the numbers that you're given. The hardest one, if we're giving you all the numbers, is to solve for velocity. So let's try that. How fast is going to tell you your speed. If it has 10 kilojoules, so EK equals 10 kilojoules, or if you want to automatically switch it to joules, the proper SI unit, that would be great. And if it has a mass of 1600 kilograms. So again, EK equals mv squared divided by 2, but this time we want to solve for this guy. So we need to get rid of everything else. Multiply by 2 to both sides. You get 2 EK equals mv squared. Now you divide by m. You get 2 EK divided by m equals v squared. Now in order to get the v squared gone, we need to take the square root. So we will take the square root of both sides, and you're left with the square root of 2 EK divided by m equals v, which would be 2 times our 10,000 joules divided by our mass of 1600. And if I just do all that, we have 2 times 10,000 divided by 1600. We get 3.54 meters per second. And we have 2 significant digits, so therefore our speed is 3.5 meters per second. And that's it. Okay, let's try a more challenging one. I'm going to ask you how fast a hockey puck is going if I applied a force of 80 newtons over a distance of 0.9 meters, and the mass of the hockey puck is 0.17. So what I'm going to do here is go through what I have. I'm looking for speed, and I have a force of 80 newtons, very hard force, and it's going over a distance of 0.9 meters. That's my distance, and we have a mass of 0.17 kilograms. So we don't really have a whole lot in terms of being able to plug in a formula, but if I looked at what I have velocity, I have force, I have distance, and I have mass. Now because I've been doing this for so long, right away when I see force and I see distance, I know that they have a relationship and they will produce work. But that's just because I've been doing this for so long. This kind of connection will come with practice. I also know that mass and velocity are related to each other through EK. So this kind of creates work, and this creates EK. Something tells me that work and kinetic energy have a relationship as well. I know that work is equal to the change in energy. So maybe we can solve for something. If I look at my formula sheet right now, I know I can solve for my work because I have everything I need. So let's do that. Work is equal to force times distance. If you're ever stuck, just solve for something. Just find on the formula sheet all the variables you have and solve for something. It usually will lead you to a different step. So if I solve for work, I have work is equal to 80 newtons times 0.9, which is going to give me 72, and that's going to be in joules, or Newton meters, either way. Work is equal to 72 joules, so that's now something I can add over here. I know that work is equal to the change in energy, and work is equal to 72. So 72 joules is going to equal some change in energy, which is going to be, in this case, it's all kinetic energy. The puck is assumed to be not changing height, so it must all be kinetic. So EK2 minus EK1. In this case, it doesn't tell me how fast the puck was going at the beginning, so I'm going to assume it's 0. So that would mean 1/2 m times v2 squared, our second velocity, minus 1/2 times m v1 squared. But if this v1 is 0, then this whole thing is 0. I'm left with 72 is equal to m v2 squared over 2. If I plug in my numbers, or actually I'm going to isolate for v first, because we want this final velocity all by itself. So we're going to get rid of it by multiplying the 2, both sides. You get 144 is equal to m v2 squared. Divide both sides by m, and we end up with v2 squared equals 144 divided by mass, square root both sides. v2 is equal to the root of 144 divided by m, which is 144 divided by 0.17 kilograms. And I get 29.1 meters per second. If I look at my significant digits, I need 2. So our final velocity is equal to 29 meters per second. Again, this is going to be the hardest kind of question we can ask you in Science 10. We're just asking you to relate work to energy through this formula here. So if you can do that, I have no doubt that you will be just fine in Science 10 physics, and it will positively lead you to Physics 20. For now, I'd like you guys to practice with your booklet and to start on your second assignment. If it hasn't been posted, it'll be posted very shortly. Have a great day.